Welcome everyone. This is the next lecture in the series for data structures and algorithm. Previously we talked about linked lists as well as we went over the basics of Java. Today we're going to go over the actual code for linked lists, and I decided to sprinkle in a little bit of information on adding generics as well as the toString method. But we'll get to that when we get to that. To begin with, the first thing is, I said in the previous video that we're going to do a bottom-up approach. So this bottom-up approach is, we're going to first look at the main function, understand how the things work a little bit, look at the node, and then the linked list, and make a full circle back to the main. Now, at this main function, we see that we can implement a linked list of type string called list, and then from this new linked list of type string, we're going to add different things. So in this case, we're going to say the linked list is named list. We want to insert into the end John, Apple, Mike, or Duck. And then we can also have a function, just for fun, insert to the front of the linked list. We also talked about in the previous lecture, remove front, and remove end. Now, if we run this code, we should see the following. John, Apple, but wait, we're adding to the front, so it should be now Mike, John, Apple, and then Duck. And let's comment everything out for the moment. And if we run this, we do see Mike, John, Apple, and then Duck. So nice. The linked list seems to be working. But now, how exactly does it work? Well, let's first look at the linked list node. The linked list node has two variables associated with it. We used to call it data. Let's now just call it the value. The value of this node is the same as the data in this node. And then we're going to say, instead of having a pointer, we're going to call it next. And next basically points to the next element in the linked list. Sometimes it'll be null, other times it'll be a new node. So now that we've implemented our class, and we have an understanding of what these two variables do, we can create a default constructor and set everything equal to null. And remember, this references a specific set of memory. So if we were able to do list2, well, this would associate it with the memory that we're using. So we can do list2 dot remove end, and this only reinforces the idea that we're working with list2. Nice. So let's go back. Now that we have an understanding of this for the constructor, let's do two parameterized constructor, one taking in only the value, and in this case you can see we're updating the value, and the next one taking in not only the value, but also the next element as well, and correspondingly updating it. Now that we have the constructors, let's implement setters and getters as well. Getters get the variable associated with them, so we have getNext, which returns next. Setters take in a new value and update the current value with that. One thing to note is we're using generics, so you see this T here. It's showing up a lot of places. Well, when we initialize our linked list node, see here, our linked list node we initialize to be a string. What Java does is it will take this string and it will change all of these T's to be a string. So if we made a linked list with int, it will change these T's to be int. Or if we change it to be a different class, it will change the T to be of that class. So that is what generics is there for, and it allows us to not have to write the same thing for different objects. Now that we have an understanding of the linked list node, let's look at the linked list. So this linked list, the first element is called a head, and that will be what we're using to reference everything else. So we initially set the head to be null, and then if you're inserting to the front, you'd say that the head would be the node. So you have your node here, your head which points to whatever it is. And then once you add the node to point to the head, you can update the head to be the node. This is how you'd insert in the front. And then you can keep doing this, adding to the front if you want. But what if you want to insert at the end of the list? Well, the first thing you have to look for is if the linked list has been initialized. If it has not been initialized, well, as previously done, you just set the node to be equal to the head. From there, if it's already been initialized and you have elements in it, we can create a temporary node called traverse, which will traverse to the end of the node, the end of the linked list, and then add the last element in. So how do we traverse this linked list? Well, we're going to make a temporary variable, again, called traverse, which starts at the beginning. And then, while we haven't reached the end, we're just going to keep cycling through. So once we hit this point here, traverse should be the last element. Well, now we can take that last element and set its next element to be what we want the end node to be. And we can update the node to point to null. So that's how we would insert at the end. What if, now that we understand how to insert at the front and insert at the end, let's look at removing from the front and then removing from the end. So in order to remove from the front, we can just update the head to point to the next element. Overall, just skipping now the first element in the node. And if there's nothing in the node, there's nothing to remove, so you can just keep it equal to null. To remove to the end, it's similar to adding to the end, except you'd want to reach the second to last element. Since this is not a doubly linked list, there is no way to go back. So if you think about it logically, after you've removed the end, the second to last element will now be the new end. So once we get to the second to last element, again, by traversing till we get not to the last element, but the second to last element, and it doesn't equal null, we can then update the second to last element to be equal to null, and the last element is now the orphan node. So circling back now to the main Java file, we understand how to go about doing inserting and removing, but one thing I mentioned is the toString. How are we able to print out our list just by sending it into the print statement? Well, in the linked list, we have this function called public string toString. Now, this toString method is called intrinsically whenever you're trying to print using system out print line. So what it does is it returns a string that's supposed to be printed. And we go about printing out our linked list by initializing a string to be empty. And I just wanted for fun to show you guys how to use a do while. So we go through our linked list until we reach the end. And once we reach the end, we add the last element as well. And what we're doing is we're basically adding the value to this empty string and adding a new line. And then this string is then returned and printed out in the print line statement. So we understand that when we run this code, we're expected to get Mike, John, Apple, and Duck. However, if we wanted to remove from the front and remove the head, we expect to see John, Apple, and then Duck. And that's what we get. Now, That's fine and dandy, but what happens with remove end? Well, if we remove the end, we're expecting to see just John and Apple. And that's what we get. So hopefully this was a way to help you guys understand how to use linked lists, as well as introduce you guys to the idea of generics and toStrings. Now I understand that this linked list is not 100% perfect, but it is only here as to give you guys a template on how to implement a linked list. Thank you for your time. Have a wonderful day.